Good morning students, welcome to physics online class. Today we can learn about Newton's laws of motion. First of all, we can learn what is motion. A body changes from one place to another is called motion. We can see some examples of state of motion. See, look at the first picture, sea surfing. Second one, high-speed train. Third one, snowboarding. So these three pictures, you can see a body changes from place to place. Next one is rest. A body does not change from place to place is called rest. Look at the picture. First picture, tools lying on the floor, bench in the park, books on the table. So these are the examples of rest. Now students, look at this picture and identify which picture shows the state of motion, which picture shows the state of rest. Now we can see the definition of rest as well as motion. First, rest. A body is said to be at rest if its position does not change with respect to fixed point in its surroundings. Then motion, a body is said to be in motion if its position continuously changes with respect to its surrounding, changes its time. Newton's laws of motion. There are three laws of motion. First one is Newton's first law. Second one is Newton's second law. Third one, Newton's third law. Newton's first law is otherwise known as law of inertia. Newton's second law is otherwise known as law of force. Newton's third law, action and reaction. First of all, we can see Newton's first law of motion. Every body continues to be state of rest or the state of uniform motion along a straight line unless it is acted upon by some external force. So this first law is otherwise known as the law of inertia. Every body continues to be in state of rest or the state of uniform motion along a straight line unless it is acted upon by some external force. So, this Newton's first law is otherwise known as the law of inertia. Now, we can see the example for Newton's first law. Look at this picture, books on the table. If we can give disturbance to the book, it changes in its state of rest to motion. If there is no disturbance, it always be in rest. So these are the examples of Newton's first law. In our everyday life, we observe that effort is required to put a stationary object into motion or to stop a moving object. If a ball is kicked into the ground, moving forever, after some time naturally stop moving the ball, continue to move unless an object of force stopped it. Here comes Newton's first law of motion. Newton's first law states that a body continues to be in a state of rest or of uniform motion unless acted upon by an unbalanced external force. To understand this, we need to know about unbalanced force. If we see in the game, you would see two teams playing a rope in opposite direction. If the rope does not move, the force is applied. The teams are balanced force. If one of the team applied greater force, pulls the other team, the ropes towards their side. In this case, the force is unbalanced force. As the force is unequal magnitude in the opposite direction, if one of the team lets go in the rope, the opposite team falls backward. This tendency to fall backward, this lets it go a rope due to inertia. If an object at rest, it tends to remain at rest. And if it's in motion, it tends to stay in motion. This property of an object is called inertia. Next one is linear momentum. Linear momentum denote the letter P. Linear momentum denote the letter P. Now we can see the definition for linear momentum. The product of mass and velocity of an object is called linear momentum. Linear momentum, what's the definition? The product of mass and velocity. The formula for linear momentum, P equal to m into v. So m means mass, v velocity. So denote P means what? Linear momentum. So the formula for linear momentum, P equal to m into v. Now look at this definition. Momentum is defined as the product of mass and velocity. The formula is given, P equal to m into v. M mass, v velocity. Now unit also we can see. What is the unit of mass? Kilogram. What is the unit of velocity? Meter per second. So kilogram meter per second is the unit of linear momentum. The linear momentum is a vector quantity. Now we can see the examples for linear momentum. Look at this picture. The impact of the force is more if the velocity and the mass of the body is more. The linear momentum measures the impact of the force of a body. So the linear momentum measures the impact of a force of a body. So you have clear about linear momentum. The important, you can learn the definition and formula. Next one is Newton's second law of motion. Look at this picture. There are two objects on the table. One has the mass 3 kg and other has the mass 5 kg. Now, if we apply the net force is 10 units of each of them, which one do you think has more acceleration? Yes, the answer is 3 kg because it has the lesser mass and more acceleration. In 5 kg, more mass, lesser acceleration. Force greater, acceleration also greater. So, from this we can conclude a formula F equal to m into a. So, m means mass, a acceleration, F force. So, force equal to mass into acceleration. From the Newton's second law we can derive F equal to ma. Important question, very very important question. Derivation we can see through this formula. Definition of Newton's second law of motion. The force acting on a body is directly proportional to the rate of change of linear momentum of the body, and the change in momentum takes place in the direction of force. Once again, definition. The force acting on a body is directly proportional to the rate of change of linear momentum of the body, and the change in momentum takes place in the direction of force. Now we can learn the derivation of Newton's second law. From the Newton's second law we can prove F equal to ma. F means force, m mass, a acceleration. F force, m mass, a acceleration. What is the unit of force? Newton is the unit of force. What is the unit of mass? Kilogram is the unit of mass. What is the unit of acceleration? Meter second power minus 2. So we can say the unit of force Newton as well as the unit of force kilogram meter second power minus 2. Now we can derive F equal to ma. Important question. The question derive F equal to ma or derive Newton's second law of motion. This is the question. First you have to write the definition for Newton's second law of motion. After that you have to derive. Okay. First we can see the derivation. After that we can learn by using this derivation we can learn the law. Okay. First, let us consider an object of mass. Suppose this is the object. This object mass is m. Okay, let us consider the object mass m moving within a straight line with the speed, initial speed u. Consider an object of mass m moving with a uniform speed, that is initial speed, that is u. Then after that time t, again the same object moving with the final velocity, that is v. Okay, first initial velocity u, next what? Final, after that time t, the final velocity is v. So let us consider the mass m moving in a straight line, the initial speed u. After that time t, the final velocity is, final speed is v. Okay, first we initial momentum of the body. Already I told momentum denote the letter P. Initial I, that is suffix. Okay, Pi, like this you have to write M U. So you know the momentum formula. What is the formula for momentum? P equal to M into V. Okay, why here U we have written, do you know? That is initial. Initial speed we have written U. No, initial velocity U. So that is we are writing here U. So the initial momentum of the body Pi. I you have to write a suffix I equal to M U. So this line all of you understand? Initial momentum of the body Pi equal to M U. Next one, final momentum of the body Pf. P means what? Momentum. F means final. So Pf equal to M into V. Okay, M means mass, V final velocity. Here mass, U initial velocity. This two line all of you understand? Initial momentum of the body Pi equal to Mu. Final momentum of the body Pf equal to Mv. Next one is change in momentum. Change in momentum. Change in momentum delta P. Delta P equal to Pf minus Pi. First final you have to write, next one initial. Okay, so change in momentum delta P equal to Pf minus Pi. So change in momentum delta P equal to Pf minus Pi. First one initial momentum of the body Pi equal to Mu. Final momentum of the body Pf equal to Mv. Next word, change in momentum, denote the letter delta P equal to Pf minus Pi equal to delta P. Delta P means what? Change in momentum. Pf, what is the value? Mv minus Pi, what's the value? Mu. Then we can take here M as common. So M into V minus U. So that is delta P. That is change in momentum M into V minus U. Then according to Newton's second law, by Newton's second law, we have learned the law, the force is directly proportional to the rate of change of momentum. Rate of change of momentum. So the force is direct. This symbol is called directly proportional. So force is directly proportional to rate of change of momentum. Okay, by Newton's second law, force is directly proportional to rate of change of momentum. So we can write here F is proportional to, here rate of change of momentum formula is change in momentum divided by time. So change in momentum divided by time. What is change in momentum? Change in momentum already we have find out M into V minus U. So we can write here F is proportional to M into V minus U divided by time. We can write T. Okay. So the force is directly proportional to rate of change of momentum. So rate of change of momentum is m into v minus u divided by t. That is rate of change of momentum. See, rate of change of momentum already we have written change in momentum divided by time. So the force is directly proportional to m into v minus u divided by t. Don't forget, first you have to write v. Some students will write first u. So that is wrong. V only first you have to write. So v minus u divided by t. Now say F means what? Force, m mass, v final velocity, u initial velocity, t time. Okay. Then here we can take this proportionality symbol and put equal to. For that you have to write one variable. That variable is k. Okay. So F equal to k into, so instead of proportionality symbol only we have to written here k. So m into v minus u divided by t. So k is proportionality constant. K is proportionality constant. K is the what? Proportionality constant. So put k equal to 1. Put k equal to 1. What answer you will get? F equal to this, instead of k you have to write to 1. So F equal to m into v minus u divided by t. Okay. Put k equal to 1. So F equal to m into v minus u divided by t. So F equal to m into v minus u divided by t. You know the formula for acceleration. Already you have learned about acceleration. Now what is the formula for acceleration? Acceleration equal to change in velocity divided by time. What is the formula for acceleration? Change in velocity divided by time. So change in velocity means what? Two velocity. What are the velocity? Initial velocity and final velocity. So v minus u divided by t. Acceleration denote the letter a. Okay, this formula you should know. A equal to v minus u divided by t. Previous classes you have learned about acceleration. No? So a equal to v minus u divided by t. Now this substitute, instead of v minus u by t, substitute the value a. So you will get here F equal to m a. Okay, instead of v minus u by t, we got write a. So we got the formula F equal to ma. This is the derivation for Newton's second law. So very important question you have to learn. Now F means what? Force, m mass, a acceleration. Okay. So from this formula itself we can learn the Newton's second law of motion. Now we can learn, see the Newton's second law. We can learn force acting on a body. F means what? Force acting on a body is directly proportional to the rate of change of momentum. This is only rate of change of momentum. Say force acting on a body is directly proportional to rate of change of momentum of the body. Okay, the force acting on a body is directly proportional to the rate of change of momentum of the body, and the change in momentum takes place in the direction of force. And the change in momentum takes place in the direction of force. So this is the definition for Newton's second law. Once again, Newton's second law definition: force acting on a body is directly proportional to the rate of change of momentum of a body, and the change in momentum takes place in the direction of force. Okay, first you have to write the definition. Then initial momentum of the body pi equal to mu. Final momentum of the body pf equal to mv. Change in momentum delta p equal to pf minus pi. Everything you have to write a suffix. Then change in momentum denote the letter delta p equal to pf. What is the value? mv minus pi value mu. Then delta p equal to m as taken as common. So m into v minus u. Then by Newton's second law, force is directly proportional to rate of change of momentum. That you know. So we have to write force is directly proportional to rate of change of momentum. Then rate of change of momentum formula, change in momentum divided by time. So force is directly proportional to change in momentum divided by time. Then again you have to write the formula, change in momentum. What is the change in momentum? M into V minus U. Time t. So we have to write F is directly proportional to M into V minus U divided by t. Don't forget, first you have to write V. Okay, V minus U divided by t. Then we have to take this proportionality symbol and put equal to. If we put equal to, put one variable. That variable is K. K is the proportionality constant. So you have to write F equal to K into M into V minus U divided by T. So K is the proportionality constant. Put K equal to 1. Suppose here 1 if you put means what value you will get? F equal to M into V minus U divided by T. So instead of V minus U divided by T, you have to write A. What's the acceleration formula? A equal to V minus U divided by T. So you will get here F equal to MA. Okay, first next line you have to write force equal to mass into acceleration. I'm writing here force equal to mass into acceleration. Any understand, students? What is the formula for force? F equal to ma, mass into acceleration. Unit also you know, the force unit is Newton. So you can write kilogram meter second power minus 2. 2 unit also force unit. Okay, Newton kilogram meter second power minus 2. Then this SI unit. Then CGS also you can write in the Newton. What's a dyne? And here instead of kilogram you have to write gram. Instead of meter, centimeter second power minus 2. Okay, this CGS system. This one what? SI system. Can you understand? So these are the derivations of Newton's second law of motion. Students, today we have learnt about motion, rest and linear momentum, Newton first law of motion, Newton second law of motion. Worksheet for you. First question, state Newton first law. Law alone you have to study and write. Then reduce the equation of a force using Newton's second law of motion. So that is this question you have to write definition first. After that you have to write this derivation I have written in a paper no. So that derivation you have to study and write. Okay. So first definition write. After that diagram no need. Just first definition. After that derivation you have to write. Study well students. Thank you.